Okay, in this question, I'm going to show you the idea of finding shortest distance. So it can be one of the difficult thing or one of the difficult method that a lot of people will forget or they cannot relate. Okay, so the first part. So when you look at the triangle, if the triangle is not drawn for you, okay, they will have described to you. So you just make sure use the description and try to draw out a proper looking one. So I already drawn it. So from here, if you look at the first part, I think the first part is quite easy. So first part is just doing a Pythagoras theorem. So you can form the Pythagoras theorem, then you punch calculator. So by now, I think it's you can punch directly, and then you take square roots. So we will reject the negative. So subsequently, this 16 can be used in the next part. So a lot of people will be will find some difficulty answering the shortest distance. So sometimes the shortest distance. So our idea of the shortest distance would be a perpendicular distance. So some cannot visualize the location. So C to AB. So C is here, AB is a line. So how do I go over? What do we mean by C to AB? How am I going to find the shortest distance? So the shortest distance is always a 90 degree. So sometimes they will ask for the perpendicular distance, but they are talking about the same thing. So usually I will use a notation, a bit of algebra. So I will use the alphabet K. Okay, because it's the shortest distance, we actually create another 90 degree. So originally there was already a 90 degree. So originally there was already a 90 degree. So 90 degree will enable us to find right area. So what I'm going to do is I'm going to find the area of the whole triangle by using the blue 90 degree. So if I use the blue 90 degree, it will be half times base times height. 16 and 30 will be the base times height. But let's say instead of using the blue 90 degree, I can also make use of the black 90 degree. But I'm still looking for the same triangle. So if I'm using the black triangle, black 90 degree, the base will be 34. The height will be K. So in this case, right, you do a bit of algebra, you got a 17K. So the whole idea is we are using different 90 degree to do a half time base times height, but the value should be the same. They should be the same value because we are talking about the same triangle. So this is what I'll call the area method. So you do a half time base times height for each of the 90 degree that you can see. So the shortest distance is 14.1 centimeter. So this will be what we call the area method. So originally there was a 90 degree already. Being the shortest distance also implied the perpendicular distance. If you didn't use a perpendicular distance, that means if you use something right here, that doesn't look like the shortest. It's actually a bit slanted. Okay, so if you slant even more, you realize that the length will get even longer. So the shortest will be where it forms a 90 degree. So that will be one of the more difficult part that sometimes you'll be asked to do.